Hello friends, in this video we will be discussing modes of data transfer, and this video is presented by S-9 group.
In this video, we will be covering these following topics. We will start with the introduction. Data transfer can be performed in three different ways. First one is program I/O, second process is interrupt I/O, and the last one is DMA, that is direct memory access. We will start with the program I/O. Program I/O is one of the techniques to transfer data between CPU and I/O module. This process basically works in these following steps. Firstly, CPU issue command to I/O module, then I/O module performs operation, then I/O module sets status bits and CPU checks the status bits periodically. Finally, processor has to wait until the I/O module completes the operation.
Here I am going to discuss about drawbacks of programmed I/O. In programmed I/O, processor has to wait until the I/O module complete the operation. Until the completion of I/O operation, CPU has to stop its operation and wait for completion of I/O operation. Hence, time wastage of CPU occurs. Introduction to interrupt-driven I/O. Interrupt-driven I/O is an alternative for dealing with I/O module. An interrupt-driven I/O is a process of data transfer in which an external device or a peripheral informs the CPU that is ready to communicate and requests the attention of CPU. Relative to total interrupt systems, the processor enters an interrupt service routine. The function of the routine will depend upon the system of interrupts, levels, and priorities that is implemented in the processor. The interrupt technique requires more complex hardware and software but makes far more efficient use of computers' time and capacities.
Now let's see the drawbacks of interrupt driven I/O. First is there are multiple I/O modules, so the processor will not be able to distinguish which module issued the interrupt signal. Second one is the processor can't decide which module to process when multiple interrupts have occurred. Now let's see the direct memory access, DMA. Direct memory access is a technique within which the main memory and external device can communicate with each other, exchange data without using the CPU. It is a way to make the processor activity faster and prevent the CPU waiting time. When large volume of data has to be transferred, it is more efficient to use the DMA method. For DMA to be implemented, processor has to share its system bus with the DMA module. Therefore, a DMA module can only use the bus only when the processor does not need it, or it must force the processor to suspend the operation temporarily. Now, when the processor wishes or it needs to read or send a block of data, it sends some commands to the DMA module. Following are the commands which the processor sends. First is the read or write command, sending through read-write control lines. Then number of words to be read or written, communicated on the data lines and stored in the data count register. Then the starting location in memory to read from or write to, communicated on data lines and stored in the address register. Then address of the IO device involved, communicated on the data lines. After the information is sent, the processor continues with other work, and the DMA module then transfers the entire block of data directly to or from memory without going through the processor. When the transfer is complete, the DMA module sends the interrupt signal to the processor to inform it that the process is finished and it can now use the system bus.
Hi, I am Aditya, and now we will just summarize what you have learned up till now. So first, let's summarize the programmed I/O. In programmed I/O, issue command is given by the CPU to the I/O module. It will check the I/O module status, then it will read the word directly from the I/O module and write it into the memory. And when the process is done, it will move to the next instruction. Then second is the interrupt driven IO. In interrupt driven IO, CPU will check the IO module and then move on. The CPU will go back to do the thing it was doing earlier. When the IO module is ready, the data is loaded, then it will interrupt the CPU. IO will interrupt the CPU and say that I am ready, now you can load the data from me, and then CPU will process it into its memory. And when that's done, it will move to the next instruction. In direct memory access, there is no interrupt and the CPU is not kept waiting, as it's directly associated with memory. So the data is directly loaded into the memory and then into the CPU. So thank you. I hope you have understood our topic of different types of data transfers.